Hello and welcome back. Let's talk about sequences. So a lot of us haven't heard about sequences before. So I guess I should first define what a sequence is. A sequence is denoted by this notation, a sub n, from n equals some value up to another value. We'll call these b and c. And so all this really is going to be is a list of numbers where we have our a term of n starting at b all the way up until our value c. And so I guess we should look at some examples. Say we could have the series of just n from n equals, say, 0 to 3. And this would just be 0, 1, 2, 3. So our n evaluated at 0. Then we go up 1, we get 1. We go up another, we get 2. We go up 3, we're at our bound. So this is our last one. We get 3, bring it out there. That's the end of our sequence. Sorry. Yeah, there's many more complicated sequences we could have. Sorry, I get these mixed up with series a lot. Series is what we will be doing next video. So let's talk about some properties of sequences. First thing we can talk about is a limiting value of sequences. And so this is basically just the limit as n approaches infinity for a sub n. So let's say for our last one where we just had n from n equals 0, but this time let's say we go to infinity because a lot of the time we'll be talking about infinite sequences. All we're going to get is the limit as n approaches infinity for n, which is just infinity. Pretty easy stuff. And so what we can say about these limits is if they equal any real value, we call our sequence convergent, and if it equals plus or minus infinity or does not exist, then we call it divergent. So yeah. I guess what I should say about it not existing would be, for example, the sequence of -1 to the n from n equals 0 to infinity. If we were to sort of graph this sequence, we would get at 0, we would get 1. Then we get -1, we get 1, -1, 1, -1, back and forth and back and forth and back and forth and back and forth. All the way until infinity. This isn't going to converge towards a value, as we know. So, yeah. But this does bring me to an easier way to evaluate convergence versus divergence. The series we just had, the sequence we just had, sorry, is called we denote it by b to the n from n equals 0 to infinity. And so for this sequence, we can say this. If b is greater than -1 and less than or equal to 1, this series will converge. But otherwise, it's going to diverge. And so there's not really a proof for this, but what we just went over kind of gives us the, like just the mindset that happens, you know? So basically if b is anywhere below -1, we're just going to get the sequence going like this and getting bigger and bigger and bigger, or just at 1 where it's the same. And the same with 1. If it was b to the 1, we would just get a straight sequence at 1. Obviously that's going to converge towards 1, or yeah, converge towards 1. But if it's any bigger, the values are just going to continue to get larger. Obviously that's going to diverge. So yeah, that's basically those. That's a pretty short part of this. But finally, let's talk about what we call monotonic sequences. So these are sequences that just increase or just decrease. And basically what we can do is we can treat a to the n as a function of n, and we can take the derivative with respect to n of the function of n. And if this is a constant or some function that never crosses the x-axis, we know that this sequence will have to be monotonic because there's no critical points for it. So yeah, that basically means, like, you know, the sequence isn't going to change direction. So we know it's just going to increase or decrease. And finally with this, we can talk about lower and upper bounds. And so basically like we had with our -1 to the n sequence, we had it going like this. We can see that we have an upper bound right here and a lower bound right here at -1 and 1. And so if we put 1 and 2 together here, we can say that if a sequence is monotonic and has a bound, it must converge, right? Because if this sequence was to just increase, it would have to stop here once we get at infinity, of course. And the same with if it was just to decrease, right? It wouldn't be able to cross this, it wouldn't be able to go back up, it has to converge. And so that's sequences. In the next video, we'll kind of be applying them with series, but I just kind of like to think of them as a completely different thing. But I hope this video helped, and I hope to see you in the next one. Thanks for watching.